this amount of storage. Then we had the major attack on web with this, which is a Fluor, Martin, and Chamier attack. So these guys had previously released paper on RC4 saying that using the 512 bytes of an RC4 stream is not a good idea because you have some information in this. But in the web case, they use it. So finally, working on them, they discovered that when you use some what they call weak IDs, then you can get informations on the key that have ciphered the packet. So in the end, by grabbing about million of packets, you can just crack the key like this. So the good thing with this attack, it's not a brute force attack, it's a mathematical attack, and doubling the size of the key just doubles the time to achieve the attack. So it's really a very effective attack. And then the last one is some optimization by a guy called Korek. So Korek has found what he called solved cases. So he can just make the Fluor, Martin, and Chamier attack much faster and rely on other kinds of packets. Because when manufacturers have seen that there was weak IV, so they said, okay, we will remove all weak IVs from our driver, and then because our access point or driver does not generate weak IVs, then that's cool. But with correct optimization, that's not the case. But all these attacks needs to gather traffic. So you have to wait to have all the traffic you need to perform the attack successfully. But if we can inject traffic, then we can accelerate them. So the thing is, it's based on this. So it's a bit of math, I will go quickly, but you can read it afterward. The basic thing is RC4 and CRC are both linear things. And in fact, just playing with formulas, you can just figure out that you can just modify a given packet on the network, a ciphered packet, you don't know the key. You can modify it in a way that CRC will still be good in the end. So that these formulas, I can just take a frame and do whatever modification I want in it, and this frame will still be correct for the Wi-Fi stack. So it can be decrypted. Decrypted, the CRC will be okay, and then we'll pass the packet to other layers. So this kind of thing is used massively for two things. The first thing is Oracle-based decrypting attack. So basically, I send frames, and I look at the answers from the network. So if I get an answer, then my packet is good. If I have no answer, then it's not good. And this way, you can decrypt packet. Or you can stimulate the network to give you answers and then gathering more traffic. So an example of an Oracle attack is a Korek Chopchop attack. So Chopchop is a way you take a frame and you will decrypt it. So basically, it's based on packet modification. Then you grab a packet and you will modify it byte after byte. And just re-injected your frame and looking at the network, you will deduce if your modification is good or not. And then you can deduce the value of the byte you have modified in the clear text. And then in the end, it's quite fast. In about 30 seconds, you have decrypted the whole packet. So it's quite easy. And this attack is used by a software called AirCrack. So AirCrack is quite a famous tool. AirCrack is a web cracking tool. It's the most efficient published for now. So basically, it will use both Oracle attacks, so Chopchop attack, to try to find an ARP request who has been answered. And once you get this packet, you just re-inject it to stimulate the network. So this packet will be answered, and then you will generate traffic. And while generating traffic, you will get the amount of frames you need to perform Fleur, Martin, and Shamir attack with optimization and so on. So nowadays, with this kind of thing, you can crack a web key of 128 bytes in 10 minutes. So 10 minutes to gather traffic and crack the key. Crack the key is 1 second, but 10 minutes. So people were telling, yeah, but I use web with .1x authentication, so the key is changing every hour. It's weak. The thing is, AirCrack, the current version, is not optimized. So you can add tests to reduce the amount of packet you need, and then the algorithm to explore the key space is not optimal. Sometimes it turns around and just can't find the key. But with some optimization, you can crack a key about 2 or 3 times faster. So it leads to things like 5 minutes. So this is the URL of AirCrack. It's very impressive. So captive portals. So commercial Wi-Fi hotspot for public internet access. Most of them relies on what we call a captive portal. So captive portal is, in fact, you have a gateway of the network will allow you to get out once you've been authenticated on a website. So typically you have a web portal with a username, password, and things like this. And when you're authenticated, you're allowed to go to the internet. So this is linked to a billing system because they won't do it for free. And the thing is with all this network is the way they are tracking authorization. So once a guy is authenticated, how do they track the authorization and not having other people use it? So that we'll see. So there are basically 3 ways of, during pen test, I've seen 3 ways of tracking clients, authorized clients. The first one is MAC address based. So the guy is authenticated, you grab his MAC address, and then you will authorize any packet with given MAC address to get out. So this is basically all these tools are based for tools that were developed for wired networks. Because on a switch wired networks, MAC spoofing is quite difficult to achieve because Ethernet switches doesn't like to have the same MAC address on 2 different ports. So they get checky or they deactivated ports, something like this. But on a Wi-Fi network or a wired network with hub, it's no problem. I mean, 2 stations can have same MAC address, no problem. So bypassing the authorization is quite simple. You find someone who is authorized, and then you will use his MAC address. To avoid any conflict, you will use a different IP. So basically, when you receive traffic with the other guy's IP, your IP stack just drops the packet silently, and it does the same. So you both can surf with no problem. So it works very well. I tried it.